Alright, it's been a while. So I think it's time to get back into it and get back to practicing. Let me adjust this screen here. Man, it's been a while since I've streamed anything. But, doing set of 4, hopefully 2 easies, 2 mediums from the top 70 interview questions. I cut out the hards because I am in no shape to do hard questions at the moment. But, let's see what we get. Hopefully it's nothing too terrible, honestly, because I need something easy. All right, let's see what we get. Please don't be okay. Ah, good grief! Why? Why is this what I have to start with? All right, Conway's Game of Life. You are given a two-dimensional matrix where a 1 and a 0 represents a live cell and a 0 represents a dead cell. A cell's living or dead neighbors are its immediate horizontal and vertical and diagonal cells. Compute the state of the matrix using these rules. Any living cells with 2 or 3 living neighbor lives. Any dead cells with 3 neighbors becomes a live cell. All other cells die. Alright, so using my somewhat... Okay, using some of kind of what I retain, I guess as a bit of a crutch here, let's oh, there's no topics, but it is a fairly large company question. So we need to calculate state of the next matrix, right? So the plan here is there's no restrictions on time complexity or space complexity, so we make another n by m matrix and iterate through it in n squared time, and just calculate the current state of each cell based on original. The thing here, right, is are edge cells counted as living or dead is my question. For example, so it says let's see, you're given, the rule is any living cell with 2 or 3 living neighbors lives. So for example, this one has 1, 2, so it lives. I'm assuming purely based off this cell that if, I'm assuming that, what's it called? Edge cells are living. So I'll just write that as an assumption. Assuming edge cells are living cells. Cool. So let's give this a shot. Just do a basic setup here. So we're gonna make a 2D integer array. Yeah, okay. 2D int array. Let's call it new state equals new int of size matrix dot length. And matrix, it's a rectangular matrix, so we can just do matrix at 0 dot length. Dot length. Okay, so what we need to do now, I think this becomes a question of bounds detection, to where you need to check for 0 and size on the edges. And if it ever exceeds that, you just add 1 to the current living cell count. So, for int I equals 0, I is going to be less than our matrix, our new state, dot, I'm going to change the name of this to next dot length, I++, sweet, okay. And then what we're going to do is go another iteration in. J equals 0. Hope my music balancing here isn't too off. Should be okay. It's very difficult to tell on my end though. J is less than next at 0 dot length J++. Sweet, okay. So what we're going to do is for each of these cells do a couple checks. We need to check up, down, left, right, and 2 corners. Okay, I guess we can we could do this using, what is it, 1, 2, 3, 4, 5, 6, 7, 8 if statements, but that seems to be a little bit redundant. So a couple things that we can say here, right? If, so I think it's I is equal to row, j is equal to column. So if I is equal to 0, then we automatically know we are at the top. So there's no point in checking those three because they would all automatically be 1s. So let's say cur live neighbors with 2 or 3 living neighbors lives. Wait, no. So this one has 2 living neighbors. So the outers are dead cells, not living cells. We are at the top, so I does not equal 0. We are not at the top. There we go. So going from here, we now know that we can check the other cells. So, oh goodness. Okay. Let's do int cur live equals 0, and we can go ahead and count the amount of live neighbors. And I think an important check to do that might save us some redundancy. No, actually it wouldn't. I was going to say between each of these if statements we could check if that current number is greater than 3, because that automatically makes it a dead cell. So we're not at the top. We can check those top 3, bottom 3. We can do the same for the bottom 3, and then just check one left, one right. Oh, wait, no. That's a bit trickier. Okay. If j does not equal 0, and not Python, okay. And using this, okay. If j does not equal 0, meaning we're not at the 0th column, and matrix at I j minus 1, I minus 1, j minus 1 is equal to 1. Cur live plus plus. So what we're saying is check top left, and we can copy this statement over and do something very similar for the rest of these. So we're going to do that and do that. So if j is also not equal to matrix at 0 dot length, this one is going to be checking the top right. There we go. And we're going to break this conditional up. It's going to be j plus 1. Okay, and this one is going to be checking directly above. I minus 1, and keep j at 0, at the same j, and we don't need to check for a j condition here. Cool. So that takes care of checking 3 out of our 8 possibilities. Great. So now, let's copy this and check below. I've always wanted to implement Conway's game of life, but I didn't think that this would be the way that I'd do it. Oh, but I see the this is gonna TLE. I'll do the optimization after, because actually, no, it actually won't. I thought I was kind of overdoing it by checking every row and every column for every single square, but I'm not, because this loop is only iterating through the matrix once. Cool. So if I does not equal matrix at 0, no, it's just going to be matrix dot length for the rows. Hey, how's it going, man? It's been a while. Okay, matrix dot length. Check top left. Okay. Then again, if j does not equal 0, we check that. But this time we check I plus 1. Yeah, I'm so rusty on all of this. It's kind of sad to watch almost, I'd say. Um, I plus 1. Great, so this should handle checking below. Then here we can just check to the left and right. There we go. Let's do that and that. So j does not equal 0. And at I, j minus 1 is 1, curlive plus 1. And j does not equal matrix, so if it's not at the right edge. Matrix at 0 dot length. And at I, but j plus 1 is equal to 1, curlive plus 1. Cool. So now we need to, let's first of all, I guess, this is still inside this loop. Okay. Oh, wait, I'm going to need to, I think, actually, oh, no, I think it should be okay. So from here, let's do next at I, j is equal to curlive. Just like that. And we're going to here, outside of this loop, return. Let's see, we're going to return the next matrix. And see how many compilation errors I have. I1 line 44, that's okay. The fact that that's the only one that there was is surprising to me. Alright, let's see. Runtime error. 4 out of bounds for length 4. Line 38. Very confused about why this is being an issue, however, because so matrix at 0 dot length. So we checked to see that I wasn't out of bounds. Index 4 out of bounds for 4. Okay, so we checked up here to make sure that it's not out of bounds. We checked here again. 0, 1, 2, 3. That's interesting. Okay, but why? So we're setting it to be the correct amount of rows. We're setting it to be the correct amount of columns. We're checking to see if I is not matrix.length. -1. Because we can't access the 0 index, we can't access that part. Matrix.length -1. That should fix that part. Okay, that handles that, that handles that. I does not equal matrix.length -1. I think there's an extra space here. Why is that there? Okay, so now j does not equal 0. We can check j -1. J is not equal to dot length -1. We can check +1. And we're checking the length -1 here as well. So matrix.length -1. Wrong answer. 2 neighbors, 3 neighbors. Okay, cool. So it is running. Now what we just need to do is set next to I. Okay. We say if so if num or curlive curlive equals 2 or curlive equals 3, then we set the matrix to be equal to 1. Next, at I, j is going to be equal to 1. Then, so any dead cell okay, so if matrix at I, j is going to be equal to 0, meaning if it's a dead cell, and curlive is equal to exactly 3 neighbors, then it becomes a 1. If I'm understanding that correctly, then we can set this up to an else if, and finish off our bracket. Alright, so, otherwise, if it's a, if matrix at ij, there you go, is equal to a live cell, and it meets these other conditions. Dead cell, 3 neighbors, lives. Live cell, and it has, and either one of these is true, it's also alive. Otherwise, we just set the cell to be dead, and we are done. There we go. And else is equal to a 0. And let's give this a run. Sweet. Please don't TLE. Sweet. Conway's Game of Life. Nice. Feeling pretty kind of confident on arrays, even after how long I've been gone for. Largest tree sum path. Given a binary tree, return the largest sum of any path between any 2 nodes. Okay. So let's see what we're doing here. So the largest sum of path between any 2 nodes. I think that's the part that is the most important to note here, is that looking at path between any 2 nodes, not between any, well actually, hold on. Oh no, okay, no. So it is different. I was initially under the impression that it was between any 2 nodes, so you could just check this node, this node, this node, this node, and so on. So how can we do this here? Obviously this is going to need to be a, it's a recursive, maybe I think a DFS would actually, wait, actually, is it going 8, 7, 4, 2? Okay, so the thing here to note, right, is we don't necessarily have to traverse back up the tree. We don't have to go from 8 to 7 to 4 to 2, right? Checking just from this 7 and recursively down gives us the still fastest path. So I think what we can do is to say keep max sum, and from every node do recursive traversal. It's a very slow solution. I know there has to be a faster one, but I just can't really comprehend what a faster one would be right now. Do a recursive BFS. Update max at each layer. Yeah, okay. I guess we could try that. I just want to look at the other 2 questions here, man. No easies. Lowest common ancestor. Given a binary tree root and integers a, b, find the value of the lowest node that has a and b as descendants. A node can be a descendant of itself. All nodes in a tree are guaranteed to be unique. Interesting one. Jeez, okay. Island shape perimeter. Oh, I love this question. Given a 2-dimensional integer matrix of 1s and 0s, where 0 represents an empty cell and 1 represents a block that forms any shape, Return the perimeter of said shape. There is guaranteed to be exactly one shape, and the shape has no holes in it. So the perimeter here is 2, 3. So it would be 1, 2, 3, 4, 5. Okay. This is going to be a BFS traversal of a graph. So we treat this as a graph. And perform BFS on it, and then we just need to find the conditions that mean add to perimeter. Okay, so I just want to check the topic. Yep, graph, got it. All right, so it looks like for this one we would be, guaranteed to be exactly one shape with no holes in it. I'm a little bit confused about how it hit 8 here, so we get 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. How do you get 8 out of this? That's my question. I guess maybe you look at this one, right? And this one has a 1, a 1, a 0. I guess you just do a BFS where you modify the matrix in place. You add all the ones in, and then you check. Actually, maybe you don't modify it in place. You keep track of your visited coordinates, I think. Either that, yeah, you keep track of your visited coordinates, I think, with a second 2D matrix. And once you've visited everything, you can calculate how much it contributes. So for example, this one would be 1, 2, 3. This one be 1, 2, 3, 4, 5. And that's already 8. I don't know how they got 8 out of this, honestly. That's the most difficult part, is figuring out what they classify as a perimeter. So let's try solving this problem, right? Because it's just a tree problem. How a path between two nodes can be maximum using their intersection node. There must be some node between them. I guess let's try my solution. It's not particularly the fastest, but I can definitely give it a try. And even if my time runs out here, I do want to solve this one, and then I want to try and solve the island perimeter one, just because I need my refresher on graphs. And given that my last 2 remaining interviews are with Microsoft and Google, it's gonna be hit for sure. Okay. So let's keep a max, right? Int max is equal to -1. Actually, let's set this to be integer min value. Okay. Okay, so integer min value, right? Now, between any 2 nodes, so I think the most difficult part here is to, I guess, post order traversal, right? So post order is where you hit the middle last, so that's left, right, and then center. Let's just see post order traversal. Okay, let's hope that the ad blocker blocks all of the invasive ads on Geeks for Geeks. Alright, so post order is left, right, root. So that was right. Okay, so let's define a recursive function. We actually need to define the max variable here at a global scope. And oh gosh, there's 5 people watching. I'm kind of impressed, honestly. 5 people watching me struggle back on day 1 of solving these questions. Keep track of the max value. Welcome everyone. Not sure how many people are first-time viewers, but this is just kind of what we do here. Keep track of max. value. Wait. Oh, wait, no, this is a bit more difficult than I thought. Because this is A742. I guess if we were to... No, it is still a recursive traversal. Let's say we'd just be hitting this 4 node. We'd be traversing left. I guess we just pass back up the maximum value. We'd have to do it... Oh, goodness, okay. It's been so long since I've written, like, any proper recursive functions. But we do definitely need a helper function for this. And I'm open to all suggestions when it comes to this, because it's... Okay, so, public... Actually, we might not even need the helper function. Because it's passing in a root and it's returning an int. No, we definitely need a helper function because, no, we don't. Okay, it's like slowly starting to come together in my head here. Because what we're doing, right, if we're, the hint mentioned a post-order traversal. Okay. Let's get rid of this. Let's just have a bit of time to think through it, okay? So, post-order traversal is left, then right, then root. So, we have our given node, and it needs to be a path between a minimum of 2 nodes. So we traverse left, then we traverse right, and we have to do some sort of comparison here. Okay, let's try that, right? Int left equals solve root dot left. And then int right equals solve root dot right. We need to consider the nodes being null. So if the node is null, then what we need to do is just return a 0 because it does not have any effect, meaning we've hit a child node, and that is not going to be the thing that we want to look at, right? So, oh, it's a good song, and I haven't heard this one in a while. Alright, so, we have our values for our left and right traversals, right? So let's say, knowing from here, given at this node, we automatically know what the maximum value is from here and the maximum value is from here. I guess what we can assume is that if adding a value makes it smaller, we do not actually want to add that value because then it makes no sense to add it. So let's do if left is greater than 0, oh man, this is such a nice lo-fi mix of this song. Okay, so int cur is equal to node dot, root dot val. So the maximum value that we could ever have for a node is the sum of it and whatever the maximum was as we went down the tree. So we take its value, right? If left is greater than 0, cur plus equals left. If right is greater than 0, what we want to do then is add the right value to it. Because if it's less, there's absolutely no point to adding it. We just want the maximum. And then to say return cur. So for this one, we would be going down, we'd be getting 0, we'd be getting a 2 here. We'd return this, it'd be bigger, so we'd have 6, we'd pass 6 back up, and then 7 would know that the largest sum of its left branch is that. Let's give it a shot. Ah, wrong answer. 36, we got a 31. How did we end up with a 36 here? So let's do this, right? Let's do our favorite printlns. We don't really have a lot of debugging tools at our disposal on this site. We're going to print out cur, and we're going to print out root.val. And we're going to do .println left, and we're going to print out left, and we're going to do print out right plus right, and println max for level, and we're just going to print out cur. I think that's what it should be. Alright, so we're going to print out cur, because we need to evaluate the entire left and right tree before actually getting to that. So let's run it. So our current that we hit here is 5. Left is 0, right is 0, 5 here is 0. But we can't... How do we hit 36 is my question, right? How did we sum to 37 on the right subtree here? I'm actually just going to pull up a calculator on my side here, just to make sure I'm not, like, missing something. Okay, 4 plus 7 plus 12 plus 4, 8 is another 12, plus 2. Ooh, but we can't consider both subtrees. We can't consider both subtrees. So, left is greater than right. Cur plus equals left. I think this is it, because we cannot consider both subtrees. We're looking for a path between two nodes, not the greatest sum up to else. Let's hope that's it. Dang it, still no. 13. 13, 13. And that max should be happening from this 4. The biggest... Wait, how is the biggest sum here? It's something small I feel like I'm missing. So we only ever want to take... I guess, so 4, we'd be going down here onto 7. Let's check the 7, right? Biggest we have... So, yeah, max for this level is the 15. That's right. From 7, we propagate back up to the 4. We have a 15, and the right is a 12. That's where we're going wrong. I just don't know how to, finish this up problem off, honestly. How do we finish this off? Okay, we're so close. I guess we'd need to, let's do this, right? We're going to take all of this, move it into a helper method. Okay, so we're going to move into a helper method, and we're going to keep a maximum value here. Value, sweet, okay. And what we're going to do is call that helper method solve2 with root. Okay, so from here, what we need to do is, even though this should work for finding the maximum at every, geez, finding the maximum at every level, we also need to do is find the max possible total and save that as well. So we're going to do int max total is equal to I think root.val. Then we're going to say is if left greater than 0, max total equals plus equals left dot left if right is greater than 0. Then we're gonna also do that this equals right, and then we're gonna do is compare this to the max that we have up top. Max is equal to math.max of max and max total. So what this is allowing us to do is basically make that connection if needed to that node. Compilation error, missing a return statement. Sweet, let's try that. Dang it, still no, huh? How did I get 313? There's absolutely no way I should have. Wait, what? Curse 5, that's min. Okay, but why is this being set to the minimum value here, huh? Did I overlap variable uses somewhere? I don't think I did. So for 5, I'm so confused by this problem. But why? You're trying to find the max sum of a path in a tree here. Yeah, let me scroll up a bit. So, trying to find the largest sum of any path between any two nodes. So basically, in this case, I'm trying to find, I think it's 8, 7, 4, 12. And I'm at the point where I have my post-order traversal working. And I have the correct, well, I mean, I had the correct numbers until I decided to go off to like 300. It was a matter of detecting whether the path that we were currently at was the maximum path, because it just wasn't adding it up. So I tried to move it into a helper method, and at every point after calculating the left and right path, see if connecting that path between those two nodes and whatever else was going on down there was greater than the current maximum that we've seen. But here, let me just put it back to what it was here. See if I can go back far enough. Because, I mean, I don't think I should need a helper method for this one. I think I should just be able to do it. Let's do this, put it back. There you go. So yeah, this was my solution that I had here for this whole time. And running through it, wrong answer was because when we did hit the 4 node, we had 15 and 12. The max for this level was 19 because you add that. But having added 15 plus 12 plus 19 would have been the correct way to do it. And I just can't think of a way to do this without a helper method. Because 15 plus 12 plus 4. Yeah, that gives us the 31 that we're looking for. Maybe... No, because we don't care about the max value of a kind of subtree sum. We just care about finding this. How do we find this? Max val is equal to 0. Min value. Okay. Let's try this, right? Oh, I see what my issue was. I think what my issue was maybe. Into cur max is equal to, say, root.val. Post order is correct if you don't need the return path itself and just set the sum. You can sum the largest subset in the set of the path itself. Okay, so I'm gonna be honest, it's been a good month since I've tackled like any sort of interview prep question, so you might have to bring that down in a bit more layman's term. You can, so just the sum, you can sum the largest subset in the set of the path itself. So like, what you're saying is to return, but wouldn't I then need to return the current maximum that I have as well to compare it against other things? Because once I find this, right, I'd be returning, I guess with one single method I can't think of a way to return it the right way. Because I guess what I would be thinking to do is to make this helper method down here, for example, public no, but that I can't return the max sum and the can't return the max sum and the sum of the subtree because I can only return one variable. Okay. Man, it's so close. I'm so sad. I wonder what he's doing. Oh, this is the... Yeah, that's the island perimeter one. Okay, let's think about this. Think about a way to do this. So how can we... So left, right, left, right, left, right. Our sums for left, right are correct. It's just a matter of using this information. I guess let's try this, right? Int cur, I'm gonna try my curmax thing. Equals root.val if left greater than 0, curmax equals max, curmax plus equals left if right greater than 0, plus equals right. There we go. Max val equals math.max. Math.max of curmax and max val. Sweet, okay. And then println max val. Okay, and now what we're gonna do think I can comment out these because I'm only interested in seeing the maximum value that I have. Does not compile. Max file's lowercase. Still doesn't compile, wow. Semicolon expected width. Oh. There we are. Just put the parenthesis in the wrong place. Yeah, so see, we do hit the 31. We do hit it. Okay. Let's try. Let's just do this again, right? We're gonna do this. Do that. Sorry. Oh, okay. I know exactly what my issue was. I didn't change the method calls from solve to. You have an exam tomorrow and you want to play me solve problems. Hey, welcome, man. I'm glad it's entertaining enough for you to avoid studying from your exam. Okay, public. Let's do int solve2 tree root. I might actually be able to get this question. Where's our method calls? Here, solve2, and we're gonna keep everything exactly the same. We're gonna get rid of this, and we're gonna call solve2 here. Can you believe it? Our grades are calculated from 100. That's so close. That's like frustratingly close. I can never. It's been a while. I can't remember what, like what year, what part of schooling you're in. Okay, solve2 with root, return max val. You know, they moved literally like 2 times 5 equals 6 on the exam. Bro, come on. You're better than that. Let's go. All right, that's two relatively. I mean, Conway's Game of Life is pretty easy. This is a more difficult medium to solve, but I mean, back on day 1, I'm feeling pretty good. Now, see, in our Calc 2 class, we were taking an exam, and at this point, you know, either it's easy to blame the professor, but I think it was we also played a part in how bad we ended up doing in the class. I think I passed by like 1%, if I'm being honest. It was not the brightest time in my schooling career, but the professor was going over the exam. Oh yeah, no. The first question was Conway's Game of Life, and I solved it pretty well, I think. But she was going over the exam the day after the class after we took it, or whenever she finished grading it, and she put up an example on the board where someone had they'd had a tangent of something, and the variable t was present, and they canceled out the variable t with the t from tangent, and somehow continued going without, you know, being concerned about the fact that that doesn't do anything. And she just kind of she was like genuinely so disappointed in us, the fact that, you know, being like almost our last kind of test or midterm or whatever, someone had canceled out the t in tangent with the variable t and called it good. It's kind of nuts when you think back to it. Okay, so largest tree solved. Sweet. I'll go back over and look at the time complexity of them once the timer runs out here. Let's see. Given a two-dimensional first try 1,000 milliseconds faster than 0.4. Yeah, no, that's just the binary search system, honestly. It's not very predictable, I guess you could say. Okay, it's good to know that I've still got my 2D array traversals mostly in the bag here. Bro. Oh my, okay, here, let me rerun my Conway's Game of Life. Yeah, no, mine's not terribly slow, I'd like to think. And I also think it's not very repetitive. Let's see. Once the timer runs out... Faster than 0.5. Oh my goodness, I remove like 10 pritlins and it goes down. That's what I don't understand. At times you remove printlins and your overall speed just goes down. So yeah, I want to go over this code, and I'm going to probably sink a bit more time into, I want to do this perimeter one just as a, oh, there you go. It's not terrible. Dude, I don't even understand how this works. Whatever, okay. 20 seconds. I want to understand this perimeter one because it's not a hard graph question in the slightest. I've done harder, but maybe it's 1, 2, 3. I don't understand the perimeter one. I think at 8. Do corners count? Alright, let's see what we got here for time. So, Conway's Game of Life. My Conway's Game of Life runs in... I'll show it in a bit. So, Conway's Game of Life, my Conway's game runs in n squared time, and as well as, I think this would be O of... I think it's n squared space, if I'm not mistaken, because we are using a 2D array. Actually, no. This is O of n space because it uses only the exact amount of space as the array that you pass in. So all I did was I made a new array of the same size as well, and then iterated through in n squared. And this if statement monstrosity here is trying to avoid as much redundancy as I could with, you know, checking, okay, is it less than this? Is it here? And is it here? I tried to blanket them with checking the top row, checking the bottom row, and then just checking to the left and right. I don't think it's an n squared, or rather n, because I've got my nested loops. Yeah, my Conway's comments. Is it n if I'm working with a 2D array? Because it's a nested loop. But is it n because the input is a 2D array? It's been so long. Alright. But yeah, then I just checked, and this whole chunk right here, the size of the input is n. Okay, yeah, that makes... So nested loop is n. Yeah, okay, so I guess it would be an O of n. So if I were given a 1D array, then it would be n squared. Okay, then this whole chunk is just applying conditions. So overall, this problem was a really nice refresher, if I'm being honest. It helped me to remember the fact that I needed to do a lot of -1s, especially on these bounds, because checking if it's less than the bound doesn't work when you need to go one past that. So next question, tree sum path. I had an idea that it was something along these lines, but it took me a lot of time to figure out, and I also think I could have gotten away without using this helper method, but I couldn't think of a way to somehow keep track of the maximum sum that we've seen overall and return that. So that's why I have a solve2 method, which does all the work that solve would do, except it also gives fourth problem. Okay, wait, hold on. Yeah, fourth problem is, it's going to be this one. You can take a screenshot of it or that, but I want to go back to this one. Yeah, that's what I'm saying. I don't understand how it's 8. So, yeah, they're literally just calculated the left and right. I guess the beauty of it being a post-order traversal in this case is the fact that at any given node, you already know what the maximum sort of winding path up to that node is from both sides, and then you can just check it. So I did that, pretty much added the left or right branch, whichever one was bigger, and continued up. And then here I calculated what the maximum possible one was at this given node, and then updated my maximum to C. Time complexity. This runs, I think, actually an O of n. Like, my initial solution was n squared, but I think this runs in O of n if I'm not mistaken. So O of n time, no extra space. Pretty neat solution. It's not the fastest by any means. Yeah, 33. I got like 50 last time. But now I want to tackle... Wait, hold on. You said you had some bad code. For Conway. I want to see this. What is going on? What is going on here? What? What kind of... What? Why are you catching exceptions, dude? Why? Why catching exceptions? Okay, I'm just trying to figure out what the heck you did. Small brain. Bro, like, hold on. I mean, mine's not too short, but... Okay, so... Mirrors is, I think, the array that you are... What? Wait, hold on. Wait. Did you fill in your mirrors array? Nested. So you have one nested loop here. I can see why you didn't just set it equal, because you can't, you know, it's passed by reference, so so you would have ended up modifying the array in place. I think I know what it is, the fourth problem. Okay, yeah, I'm gonna get to that here in a bit. Okay, so then just calculate amount of edges. That's what I think it is, but I can't count to 8 edges there. It doesn't make sense to me. Okay. Bro, I have no idea what the heck you're doing here. This is the one that fills in the original matrix based off mirrors. I'm assuming at this point yeah. Fill IJ. Goodness, dude. Okay, I can kind of see what you're doing, but this is genuinely, I think, the worst way that you could have written this. Okay, you can go ahead and fix that. I'm going to move on to this fourth one. So, island perimeter shape. So let's take this and let's try and figure out how this is 8. I guess what we can do, let's fix this indentation here. What I can do here is add 0, 0, 0. Add padding on all sides, maybe, and that'll help us understand here. If you count the edges, it's exactly 8. 1 edge here, 2 edge. So this is 1 edge, 2 edge, 3 edge, 4 edge, 5 edge, 6 edge, 7 edge. Maybe I am dumb. Hold on, maybe it is 8. And I guess add the same thing below here. Might be a bit of an easier... You forgot one, yeah, I figured. Okay, so we have... So we don't count diagonal edges, it's just top edges, right? So this would be 1 here, 2 here, 3 here... Or wait, 1, 2, 3... 4, 5, 6... Nope, okay, so 1 here, 2 here, 3 here, 4, 5, 6, 7, 8. Okay, wait, so starting from the top. 1, 2, 3, 4, 5, 6, 7. Where am I forgetting one? I guess, okay, the logic with this problem, right, is to do that fill, do that BFS, and then say if it is on if any adjacent edge to find the cell. Hey man, good to see you. Welcome. I get the feeling this is going to be very similar to Conway's Game of Life. 4 minus neighbor count. That would be it. Think of 3 ones as a polygon, like a combination of 4 squares. Okay, like a combination of 4 squares. Why would it be a little bit confused as to the fact as to why it would be 4 squares rather than 3? Okay, so yeah, okay. If any adjacent is out of bounds, add 1. Yeah, 3 squares. Okay, that makes more sense. I guess the issue here is then if equals 0, add edge, update tracking matrix. If you count the outer edges of those 3 squares, you get 8. Yeah. So update tracking matrix to show that you have accounted for that edge. And I think this should be a solution. Perform BFS. So yeah, this would be 1, 2, 3, 4, 5, 6. Okay, there can only be one island. Considering that you can just traverse the island for finding one cell, it should be easy enough. Yeah, that's kind of the goal here, I think. Just perform one BFS, and then once you find it and perform the BFS, you're just done. Okay, so let's start writing out a solution here. So first of all, I'm going to set up a flag to say Boolean found island. Found island equals false. Then we're going to traverse through the 2D matrix. Actually, we're going to keep a matrix. So I guess the only question is, like, right, if we're up at an edge and we check up above it, no other, because we're not accounting for diagonals, so no other cell can have that as a part of its perimeter, so we don't really need to check that. And what I want to do is say for int I equals 0, I less than matrix.length I plus plus, do the inner loop. Man, I'm impressed at how easily I'm kind of jumping back into these. I haven't hit anything that's like stupid difficult just yet, but it's a nice refresher. If found island, then return count. Int count. I think we've got to make int. Okay, let's do int count equals 0. If I matrix and I don't actually think we need to do any sort of like keeping track matrix. I'll just set them to 3. New vim or just stuck with VS Code. Didn't mean cut. No, I've stuck, I think, with pretty much VS Code for my development. The amount of plugins that I have installed for this thing is nuts. Like, I can maybe show off my list of plugins, but goodness, it's like, I think, 15, 20 of them. I had Vim key bindings for VS Code for a while, but I found that, like, no one can surpass me. Yeah, I'm just... Good. Is there a way for you to, like, export that list of plugins? I would be very interested in seeing what that is. Is equal to 1. Meaning we found an island. Oh, wow! Now run it again. Multimodal guy, so I have plugins for literally each language. Yeah, no, I stick to using, like, I know you can't really see my my taskbar down here, but I have a, I tend to swap IDEs for languages, just because what's it called? I don't know, the colors, I've gotten so used to the colors, I can't use anything besides, like, the VS Code default color scheme for JavaScript, because I just recognize, like, functions, variables, like, imports, and things like that. Okay, let's do BFS. BFS on I for matrix. Code blocks for C++. Nah, I haven't properly used C++, but Google Chrome for JS. Python idle for Python. I think Python, is there a PyCharm I had installed, or I think I actually ended up using VS Code for Python, oddly enough, because the color scheme, for some reason, Python is just yellow in my head. Let's see, down here. No, because when I was writing a paper on C Sharp, I installed Visual Studio, and let me tell you, man, it looks like it's like out of the 90s. I don't like the fact that by default it, what's it called? It defaults to setting up your parentheses like this. Makes me very uncomfortable. But it's like, it's the older style, so if all the rest of the code in it's written like that, you kind of have to follow it. I think the one thing that we spent like 4 or 5. It's a chunky IDE. I mean, thankfully my PC is powerful enough to pretty much just plow through anything if I really needed to. But I don't know, I wasn't a fan of it. Like, I tried setting up a C Sharp like interpreter in VS Code, but it was more hassle than it was worth, so I just installed Visual Studio. Okay, so what we're gonna do is we're gonna start our BFS from these chords. So we're gonna say, we're gonna make a queue of, oh man, how do we actually, hold on. How do we store points? OmniSharp and VS Code? I've never heard of that. I'm gonna just kind of save that for later. So I'm gonna need some help here. How do I do this on a 2D matrix? How do I store, like, because I need to know where to go next. This is where I'm kind of stuck. I think this is a similar place to where I got stuck on my Google internship interview, and I ended up doing some weird like list of maps of like one single key. It's very, very weird, very unproductive, and that's why I failed. How do I do this? I can't. Man, I can't remember how to write a BFS. Oh, jeez. How do I write a BFS? Because I could just use the Java point object, but that doesn't work in interviews because they want you to use standard libraries. Oh wait, I'm dumb. I'm dumb. I'm dumb. I don't need to do that. I don't 2D linked lists. No, I don't. I don't actually need to do that. I just check the current one, and I just pass. I just go up, down, left, right. That's what it is. I don't need to use a queue because this is a different kind of BFS. Yeah, yeah. Okay. For this representation, it's a lot easier. I was thinking of a adjacency list representation, and I was trying to use an adjacency matrix as an adjacency list. So what we're gonna do is say check. Okay. Okay, so for oh wait, maybe I do. I need to keep a separate matrix to see where I visited. Okay, so maybe we don't need this. We don't need that. Maybe we do? I don't think we do. Man, remembering graphs when I wasn't too strong at them as is. It's going to be a recursive BFS still, so matrix So we're going to say if I greater than 0, scan the 2D array with the first thing, check forward directions, start with 4 points in total for that element for each adjacent one, and continue recursively. I think I'm going to do it the other way down, or I'm going to add up instead. Because things don't share edges. There's no edge overlap, I don't think. So int amount equals 0 if I is greater than 0, and if I equals 0, then we know to the right is an edge. I greater than 0. Else if I minus matrix at I minus 1. How many applications did you send out? I think around like 150 so far. Yeah, I just had some complications with some offers, so kind of back on the lookout here. That's okay though. I got my Microsoft Final and my Google Final upcoming this month, so hoping to land one of those and just move forward with that. There we go. So this should take care of that case. Should be in less than or equal, actually. Yep, take care, man. Thank you for stopping by. I appreciate it. I'm just going to try and solve this problem. I refuse to give up because, I mean, I feel like I'm pretty close in terms of solution. Matrix dot length. You got the big gun on this problem. I think it's a good question actually, because the graphs are usually like v plus e, v times e, depending on what you're doing. I think this is a v times e runtime, whatever that might be. Matrix dot length. You got the big L on this inventory. Yeah. Nah, I got it. It's gonna be okay. We're gonna solve it. Greater than or equal to matrix dot length minus 1. Right. Yeah. Take care, man. Thanks for stopping by. Okay. I is less than or equal to matrix dot length minus 1. Then we add it to plus 1. Then if I plus 1 j is equal to 0, we all add 1 to the amount. Let's do top and bottom. J less than or equal to 0. I j minus 1. Matrix at 0 dot length there we go, and now this should add up. Then we're gonna do matrix at I j is going to be equal to something like 3, which we should never really see, and that should stop us from revisiting points. Traverse in 4 directions. BFS for matrix I plus 1, j, j that. All right. Left, int up and down. +1, j -1. Well, how did I switch to a whole other desktop? That was weird. Didn't know there was a keyboard shortcut for that. All right, and then down j -1. Then return cur or amount plus up plus down plus left plus right. And I think that should allow us to do what we're trying to do here. Basically just gathering the sum total and recursively returning that sum. Try it. Matrix 0.length. Missing a return statement in right here. Yeah, for sure. Exclamation point room, exclamation point join. Either of those should give you the key to it. Okay, let's see what we got. Line 53. Line 67, I think, is the one where it breaks. 67 to 67 to 53. A little bit confused as to how this is out of bounds for out of 2. Oh, I see, because I in this case is I is too big. So I guess I just gotta add those checks in here. What problem is this? This is island shape perimeter. It's a bit of more of like a, maybe not a difficult graph problem. It's just my first day back after about a month of off time, so it's definitely a challenge to get. So yeah, you feel free to hop in with the exclamation point join. Okay. So this isn't the issue right here. This is if I greater than or equal to 0 and I less than oh, my cat decided to wake up. I less than matrix.length. You gonna keep yelling? Hold on. Gotta let the guy out. He didn't wake up and choose violence, he woke up and chose to just yell. Alright, so I greater than 0. That. Let's run it. Still line six. Okay, line 65 is where it ends. Flood fill. It might be a flood fill. That's kind of I think that's what I'm trying to achieve here in a way, by using a BFS to fill it. I'm trying to figure out where my out of bounds is and why it's there. Oh, I see. I greater than or equal to 0 and I less than matrix dot length and j greater than or equal to 0 and j less than matrix 0 dot length. Just align that up. Make sure that we get that to be kind of where we need it to be. I'm expecting this to just crash and continue to crash until I add, yeah, so 2 out of bounds for 2, it's the j. J greater than or equal to 0 and j less than or less than matrix length. See? Line 41 still. What the heck is J here? I'm like determined to solve this. I've been at this for an hour and a half. I see. I see what the issue is. Still too high up. That's still out of bounds. Yeah, I think my brain's fried, honestly. I had the right idea. At this point, it's a matter of just like edge detection and bounds and things like that. Might come back to this problem a bit later. Let's add to a list of come back and solve the right way. But yeah, I think that's gonna be it for me for today. Solve 2 mediums. Honestly, a lot better than I was expecting. Make an inbounds method. But the thing is, I need to... Oh, you're a genius. Hold on, hold on, hold on. I don't know why I didn't think of this. Hold on. We're just gonna do... Okay. Let's do that. This is the big brain solution that we needed here. Okay. There we go. Easy. Cool. Then up here we can just say if there you go. Right, forgot you have to specify these types. Too much JS work recently. Eesh. Okay. Stack Overflow. We end up with infinite line 72, line 73. Oh, great. My mouse is dying as well. Yeah, it's missing an exit method. It's right here. It keeps looping back and forth. I thought I fixed it by setting it to 3, but I forgot to actually... You know what? Let's just do this the hard way, I guess. If in bounds matrix I plus 1 j and matrix I plus 1 j equals 1, then we go ahead and do this. It's not the cleanest way, but it's gonna work. It's just a matter of it's a matter of keeping track of where you have been and haven't been. Yeah, I'm not proud of the solution to this, like in the slightest. But it's going to be a solution that hopefully works. This one's actually down because we're moving from top left. I feel like when doing these practice sessions, you should never really go over like an hour, because after a certain point, you start to just... the quality of your solutions drops very, very quickly. I don't know how people will do this for like 40 hours a week and not be brain dead. Granted, those are the people that are getting the job, so maybe they're doing something right. Okay, down. Let's do this. J minus 1, J minus 1, go up to minus 1, and it's going to be up. Does not compile. J plus 1. Wait, if we're going up, it's going to be minus 1, not plus 1. There you go. So it doesn't compile. Where? Where? Why? Why no compile, huh? Line 82. J minus... Where's my 1? Why is there no 1 there? Okay. Still compilation errors. But it was initialized. It is initialized to a 0. Does this not work? Zero, and down. Index out of bounds, line 61. Where? Forgot to change it to a J, didn't I? Haha, let's go! Alright, well, I mean, that's 1. edges. Honestly, did not know. Oh, you solved it all. Wow. You see, but why? Why? Huh? I guess it finds that and it goes there. Honestly, I think I'm gonna leave this problem here. I'm pretty proud of myself for remembering how to get even this far, but I'm starting to think I way overcomplicated it somewhere. And at this point, I'm a little too brain dead to even know where. So, I think that's gonna be it for me today. Thanks everyone for stopping by. Probably gonna be at this another, 5 days a week for who knows how long. But, back on the stream, back on working on these problems, hopefully getting a job. Take care.